Hi again. In a previous video we did a parametric equation, and we did x is equal to 3 cos 2t and y was 3 sine 2t. And what we ended up finding was that we solved for x and y. We've got x squared plus y squared is equal to 9, which was our circle, terrible circle, radius 3. Now that was for unlimited time, so there was no restriction on time for this particular question. But what would happen if you saw the question and it was restricted to time from between 0 and to 3 pi over 4? What would happen? Because here we just went away merrily. It was just going around and around and around and around and around the circle forever because there's no restriction on time. But what happens if we only want to know for certain times? What happens to the particle between times equal to 0 and time equal to 3 pi and 4? What happens to it? It might not be the full circle, it might be part of a circle. And so let's just have a look at that. And I alluded to this in the previous video, and I think I made a mistake in the previous video with some of my cosines, so I apologise for that. But we'll go through that again. So what happens when time's equal to 0? What happens when time's equal to 3 pi and 4? Let's have a look at these things. What's going on? So when time's equal to 0, when t is equal to 0, what is the value of x? Well, cos of 0 is 1, and 3 times 1, so when time is equal to 1, our position is 3. What about the y value when time is equal to 0? Well, sine of 0 is 0, and 3 is 0, so it will just be 0. So if we drew down here, so here's our point here, 3, 0. So when time's equal to 0, it's sitting down here. When time's equal to 0, the point is here. Alright, what about the end point here, the end point of our problem? Where does it finish? Well, it finishes when time's equal to 3 pi 4. So let's have a look at that. Let's substitute this in. What's the x value when time's equal to 3 pi and 4? So 2 times 3 pi and 4 is 3 pi on 2. Cos of 3 pi on 2. Cos of 3 pi on 2 is equal to 0. 3 times 0 is 0. So the x value is 0. Times equal to 3 pi and 4. So sine of 3 pi on 2 is equal to -1. So 3 times -1 is -3. So when time's equal to 3 pi and 4, we're going to get this point down here. When time is equal to 3 pi on 4. And remember, it's still following the same path, we just don't know what part of the path. So we'll just draw it in like that. There's our circle of x squared plus y squared is equal to 9. What part of this path is being used? Well, look, here's times t is equal to 0, and here's time t is equal to 3 pi and 4. So it would be reasonable to assume that the path would be here. That we would draw this in and we're finished. But actually this is not right, because we need to check other values. Let's just check another value of time. Let's just see what happens in the meantime. Okay, just put it back to black. So when time is equal to, well, what's in between this? What's nice and easy between there? Let's just try pi over 2. Between these two values, when time is equal to pi over 2, what is where is the particle at? Well, cos of pi is equal to -1, and so the particle is at -3. Sine of pi is equal to 0. 3 times 0 is 0. So when time's equal to pi on 2, your particle is actually here. And because that's in between those values, the particle is actually going in the opposite direction to what I said before. So in actual fact, between there and there, it goes around, around, around in this direction. It moves in this direction, around this way, and then stops here. And so that is actually the answer. If you're asked to plot the path of x is equal to 3 cos 2t, y is equal to 3 sin 2t for these values of t, then it will look like this. So this is sort of like a little quick way that you can do it, a quick way to be able to sketch this. And so that's sort of the first method to be able to do that. The second method, the second way that you could do it is to think about what the functions of these look like. what does the function x equals 3 cos 2t look like? Well, if you quickly draw it, cos will start up here at 3, and this is where you need to know your functions, and it's going to sort of go like this, and instead of being 2 pi up here, because it's been dilated by half, it's going to get all squished, so that's actually just going to be it's going to be 4 pi there. 4 pi? Sorry. 2 pi. 2 pi. Pi there. Okay. And so that means that this is pi on 2, and that's pi on 4, etc. Okay, pi on 4, that's 3 pi on 4. That's your function there. So that's x. That's t, sorry. And that's x. So that's your function there. So if you have a look at this, what's happening between t is equal to 0 and 3 pi and 4? Well, what is the range of x? What's the range of your x values? It goes between 3 and negative 3. So between 3 and negative 3, it does that full width there. Okay, and what's the other? What's your y? Y is equal to 3 sine 2t. Which, what does that look like? Well, it's going to start from there, it's going to go up and down, etc. And that point there, instead of, because it's been dilated by a factor of 2, that means that this will be pi here, and that'll be pi on 2, etc. What's the range of this? The range again is of the y function, t, is the full spectrum. So this actually doesn't help you in this case, because it doesn't, the range of the x function and the range of the y function will tell you the domain and range of the final function, but that actually does not help you, because you need to know both. So this quick way is perhaps a good way to check which parts of the circle need to be plotted when you're doing a parametric equation. This is a really important part of specialist maths. You need to be able to do this. So this was not the best explanation. I did a better one in class. I perhaps will do this again in class. So ask me if you do not understand this, because I will show you this one in class. Thanks.